Today we're going to be simplifying radicals, and before we start we need to make sure we know the terminology. So please write in the square root of a so we can label this with all of the appropriate terminology. The square root symbol is called the radical. A radical can represent a square root, a third root, a fourth root, etc. if we change the index. Sometimes there's a number that is written in the checkmarky part of the radical sign. That is called the index. If there's no index shown, that means it's a square root. So nothing, we assume it's a square root. The number underneath the radical is called the radicand. A simplified radical expression has no perfect square factors under the radical except for one. There's no fractions under the radical, so the radicand can't be a fraction. And there can't be any radicals in the denominator of a fraction. So we're going to go through the process of simplifying each of those. The property that we're going to use today is if we have the square root of, say 18. We can break this square root up into the square root of 9 times the square root of 2. You can break up a radicand using multiplication. The important thing is that you remember that both of these radicands still have a radical over them. The helpful thing here is, if you make sure that this first one is a perfect square, what is the square root of 9? 3. So this becomes 3 times the square root of 2. That is a simplified radical. There are no longer any perfect squares underneath the radical. There's only 2, and you can't break 2 up anymore. No. 3 is an integer in front of the radical. So it's the integer 3 times the square root of 2. If you wanted to plug this into your calculator, you would type in 3 times square root 2 equals, and it'd be the same as the square root of 18. Okay, turn to the next page, and I believe we just did number 1. But before we do number 1, I would like you to write a list of perfect squares at the top of your page. So our perfect squares are 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 64, 81, Now, some teachers expect you to have up to 12 squared memorized. That's great. If you happen to know 13 squared is 169. And if you know 13 squared, 14 squared is really easy because you reverse the second two numbers. And then 15 squared is 225. So our goal here is going to be to break up the radical into the largest perfect square times something else. So with 18, you wouldn't want to break 18 into 6 times 3 because 6 and 3 are not perfect squares. So instead, like we did on the previous page, we break it into the square root of 9 times the square root of 2. Please do not be lazy. Make sure you keep the radicals on your numbers at this step so that you remember what has a radical on it and what doesn't. The only time that you don't write the radical anymore is after you have used the radical to change the number. So what is the square root of 9? 3. So we use the radical to change that 9 into a 3. Whole number, integer 3. So the simplified radical is 3 times the square root of 2. The square root of 72. How can we break up the square root of 72? Okay, 9 and 8 is one way. Is there a bigger perfect square that works besides 9? $36 and 2. The square root of 36 is 6. So this is 6 times the square root of 2. Now, what happens if, instead of doing 36 and 2, what if you did break it up into the square root of 9 times the square root of 8? The square root of 9 is 3, but 8 is not fully simplified. There's another perfect square that exists inside 8. So then you'd have to break up the square root of 8 into the square root of 4 times the square root of 2. So you'd have 3 times 2 times the square root of 2, which is the same as 6 times the square root of 2. So yes, you can get the same answer breaking it up into smaller numbers. It's just going to take you more steps. So if you can find the biggest possible perfect square, it's going to save you in the long run. So try number 3 on your own. Go. Square root of 48. Now when I think about 48, 4 pops into my head. I know that I can do 48 divided by 4. But here's a good hint. If 4 works, try 16. Because if 4 works, there's a chance that 16 is also going to work. So this can break up into the square root of 16 times the square root of 3. The square root of 16 is the integer 4. So our answer, our simplified radical, is 4 times the square root of 3. 7 times the square root of 24. For right now, we're going to ignore the 7, but we can't forget that it's there. So take the square root of 24, and we need to simplify that. What is the largest perfect square that we could break 24 into? I think it's 4. 4 times 6 is 24. So the square root of 24 breaks into the square root of 4 times the square root of 6. The square root of 4 is 2. Now that you're done with breaking it apart, now you have to remember the 7. So you have 7 times 2 times the square root of 6. So 14 times the square root of 6. Okay, we're going to skip number 5 and go straight to number 6. You can multiply integers and integers. You can multiply radicands and radicands. But you cannot multiply integers and radicands. So the 4 and the 3 can be multiplied together to give us 12. The 18 and the 10 can be multiplied together to give us the square root of 180. So again, don't forget about the 12, but kind of ignore it for right now. And work on breaking down the square root of 180. Think about what's half of 180? 90. So I'm going to start with perfect squares that are close to 90. I would try 180 divided by 81. I get a decimal. 180 divided by 64. I get a decimal. 180 divided by 49. Decimal. 180 divided by 36. I get 5. So 36 times 5 is 180. So I can split the square root of 180 into the square root of 36 times the square root of 5. The square root of 36 is 6. So now we have 12 times 6 times the square root of 5. What is 12 times 6? Nope, not 28. 72 times the square root of 5. So if we have the square root of 36 over 25, it is not okay to have a fraction under the radical. So we break this into the square root of 36 divided by the square root of 25. We can split up radicals using multiplication. We can also split up radicals using division. Now, on the top, what is the square root of 36? What is the square root of 25? So that one's done. The next one. On the bottom, we have the square root of 36. What is the square root of 36? 6. So on the bottom of the fraction, we have 6. However, on the top, the square root of 75, we need to simplify that. So think about your perfect squares. What could you break 75 into? Square root of 25 times the square root of 3. So on the top of this fraction, we have 5 times the square root of 3. It is okay to have a square root on the top of the fraction. It is not okay to have a square root on the bottom of the fraction. Now we do number 9. We have the square root of 6 over the square root of 5. Can we simplify the square root of 6 or the square root of 5? No. So we're stuck, and the problem is we have a radical on the bottom. We are not supposed to have a radical on the bottom. So, do you all agree that I can take something, multiply it by 1, and I haven't changed it at all? Can we agree on that? Multiply something by 1, you haven't changed it. I'm going to multiply this by a fancy version of 1. The square root of 5 divided by the square root of 5 is 1. I'm multiplying the fraction by 1. I'm just using a unique version of 1. And the reason I'm doing this is, on the top, we now have the square root of 30. On the bottom, what is the square root of 5 times the square root of 5? It's the square root of 25, which is 5. Now think about 30. Can we break 30 up into a perfect square times something else? No. So we are done. Square root of 30 over 5. Try number 10 on your own using what you just learned in number 9. So the only problem here is that we have the square root of 3 in the bottom, and we can't have a radical on the bottom. So I'm going to multiply by my fancy version of 1, square root of 3 over square root of 3. I chose square root of 3 because that's the offending square root in the denominator. So on the top, you cannot multiply the 2 and the 3 to get 6. It has to be 2 times the square root of 3. And on the bottom, square root of 3 times square root of 3 would equal the square root of 9. And what is the square root of 9? 3. 2 times the square root of 3 over 3. Now, if you had something like 4 times the square root of 3 over 8, you can simplify the integer part of that fraction. That would simplify to the square root of 3 over 2. So just keep that in mind. The integer parts you can simplify. All right, number 11. We split it into the square root of 45 over the square root of 32. Take a moment and simplify each of those radicals, and then we will continue. So we're going to break up the square root of 45 with square root of 9 times the square root of 5. So on the top of this fraction, we have 3 times the square root of 5. 32, I'm going to break up with 16 and 2. So on the bottom, we have 4 times the square root of 2. By simplifying both the numerator and the denominator, we now know that the only bad thing in here is the square root of 2. So to alleviate that problem, we are going to multiply the top and the bottom by, oops, not the square root of 5, by the square root of 2. On the bottom, you have 4. What is the square root of 2 times the square root of 2? The square root of 4, which is 2. And 4 times 2 is 8. So your final answer is 3 times the square root of 10 over 8.